Here's how you can find the zeros and relative maxima and minima of a polynomial like this one without even having to graph it. Let's help you understand what it is that we're finding without graphing. I'm going to have to show you a graph. So first of all, we need to find the zeros of the polynomial. And that's basically wherever it crosses the x-axis. It's wherever y is 0. Remember, y is up and down. So where y is 0, that means we're not going up or down at all. So like, for example, right here. Here, we're just staying on the line. We're not going up, we're not going down. So this is a 0. And we represent zeros by where they are relative to x. So in this case, we started in the middle and went to the left, 1, 2, 3, 4. Remember, to the left is negative numbers, so we would say that we have a 0 about at x equals negative 4. What about this one here? This is also a 0 because it crosses the x-axis here. This is where we're not going up or down. And this is probably about x equals negative 1 because we went to the left 1. So this is about at x equals negative 1. And then this one's kind of in between two values. This is between x equals 2 because it's 2 to the right and x equals 3. So we're just going to say between x equals 2 and x equals 3. And you'll see that once we start doing our table and we're solving this without a graph, we're probably just going to say, oh, it's between these two numbers, because that's basically as specific as we can get. Now, what about relative maxima, which is just the plural word? Maxima is the plural word for maximum, which is probably a word you've heard before. It's just the biggest value. But a relative maximum is basically the maximum value just within a little small space. So in that case, it would be right here. This is a relative maximum. It's the top of a little hill. It's not the biggest value in the graph because there are numbers way bigger than that over here, but it's the biggest relative to where it is. So this is going to be a relative maximum. It's actually the only one, and it's going to be between these two values. Here we have x equals negative 3 because we go to the left 3, and this is x equals negative 2 because we go to the left 2. So this is going to be between x equals negative 3 and x equals negative 2. And now finally we have relative minima, which is just the same thing, but it's the smallest numbers in a little area. In that case, we only have one here, and it's this one. This is the smallest number in this little valley here. And it looks like it's between x equals 0, which is just right on the line, and x equals 1, which is 1 to the right. So we're going to say that this is between x equals 0 and x equals 1. So this is how you find zeros and relative maxima and minima on a graph. But how do we do this without a graph? Well, here's the example that we'll be doing in this video. We need to figure out the zeros and relative maxima and minima of this graph right here, except we're not going to graph it. We're just going to figure those out without having to draw anything. So we're going to be doing this very similar to how you would sketch a graph of this, except we're just not going to do the plotting the points part. So when we're sketching a graph of something like this, we always do a table. So we plug in numbers for x, see what we get for y. We just do that a bunch of times, and then we have a rough idea of what the graph looks like. So we're going to have an x column and a y column. And for every number that we plug in for x, we'll get a number for y. And we'll do that multiple times and see what we get. So we're going to start as far to the left as possible without going too crazy. I think I'm going to try out negative 3 and see what happens. And then we'll do negative 2, negative 1, and so on. So we're going to rewrite this equation, except whenever we see x, we're going to put negative 3 instead. So we're going to have negative, and instead of x, we're going to put negative 3. So we're going to have negative 3 to the 4th, plus negative 3 to the 3rd, plus 4 times negative 3 squared, minus 3 times negative 3, plus 1. Now, negative 3 to the 4th, that might be a little hard to think of in your head, but we're going to have negative 3 4 times. So we're going to have negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3, well, that's 3 times 3, which is 9, and then two negatives make a positive. So it's going to be positive 9. So we're going to have positive 9 times positive 9, and 9 times 9 is 81. So we're going to have 81 for this. But remember, we actually have a negative sign here. We have another negative. We have negative what we just did. So this is actually going to be negative 81. Next, we have plus negative 3 cubed. Well, that's negative 3 times negative 3 times negative 3. And remember from before that negative 3 times negative 3 is 9 times negative 3. 9 times 3 is 27. And we have one negative sign, so the negative sign stays. So we're going to have plus negative 27, which is just the same thing as saying minus 27. Next, we're going to have plus 4 times negative 3 squared. That's negative 3 times negative 3, which is positive 9. So we're going to have positive 9. And then negative 3 times negative 3, that's showing up a lot in this problem, but it's the same thing. 3 times 3 is 9, 2 negatives make a positive, so plus 9. And then plus 1. All right, so next we're going to have negative 81 minus 27. That's going to be minus 108. You can put that in a calculator if you want, obviously. And then plus 4 times 9, which is 36. And then plus 9 plus 1. 9 plus 1 is 10. And now we can just do this in any order, but if you wanted to put this in your calculator, minus 108 plus 36, that would give you negative 72, and then that would give you negative 62. Again, this is very calculatorable. But yeah, our final number here is negative 62, which kind of makes me thankful that we're not actually graphing this because this would be literally impossible. All right, let's go ahead and do the same thing for negative 2. Let's go ahead and put negative 2 as our next number. So we're going to do the same thing, but instead of x, we're going to put negative 2. So negative 2 to the fourth plus negative 2 to the third plus 4 times negative 2 squared minus 3 times negative 2 plus 1. So negative 2 to the fourth, well, let's go ahead and write that out. Negative 2 times negative 2, that's 2 times 2, which is 4, and 2 negatives make a positive. So we're going to have 4 times 4, and 4 times 4 is 16. So this is, remember, we have a negative sign here as well that we hadn't used. So it's going to be a negative 16. Then we have plus negative 2 to the third. That's negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4 times negative 2. 4 times 2 is 8. And we have a minus sign, so the minus sign stays. So we have plus negative 8, which is just minus 8. Then we have plus 4 times negative 2 times negative 2, which is positive 4. Then we have negative 3 times negative 2, a little bit different this time. Woo! 3 times 2 is 6. And then we have 2 negatives make a positive, so positive 6, and then plus 1. Negative 16 minus 8, we lost $16, lost another 8, that's minus 24. Then plus 4 times 4 times 4 is 16, plus, and 6 plus 1 is 7. And now, again, you can always put this in your calculator if you want. We have negative 24 plus 16. If you want to think about it like the dollar analogy as well, you lost $24, then gained 16 back, you're still down 8. And then you gain another 7 back, but you're still down 1, so negative 1. So already we've gone from negative 62 all the way to negative 1 in just one amount of x. So next, let's go ahead and try out negative 1, and it's the same thing over and over, so I'm going to go a little bit fast, but again, you're always free to pause the video and think about what it is I'm doing. But it's the same thing that I was doing before, just with a different number for x. So we're going to plug in negative 1 wherever we see x. So here we have negative 1 to the fourth. Well, 1 times 1 times 1 times 1 is still 1, so the 1's not going to change. But because we have an even numbered exponent here, that's negative times negative, which is positive, times another negative, which makes it negative, times one more negative, which makes it positive again. So this is actually going to be positive 1. But we have another negative right here, so that makes it negative. 5 negatives, not confusing at all. Then we have plus negative 1 to the third, that's negative 1 times negative 1, which makes it positive 1, times another negative 1, which makes it negative. So that's going to be negative 1. Then we have plus 4 times negative 1 squared, that's negative 1 times negative 1, which is positive 1. Then we have negative 3 times negative 1, 3 times 1 is 3, and 2 negatives make a positive, so positive 3. And then plus 1. Minus 1, that's minus 2. Plus 4 times 1 is 4. Plus 3 plus 1 is 4. So here we have negative 2 plus 4. That's the same thing as 4 minus 2, which is 2. And then plus 4 is 6. So we're going to have 6 for y. And now let's keep going. So we're going to have 0 for x. This should be the easiest one. And this is quite easy because 0 to the fourth is 0, 0 to the third is 0, 0 to the second is 0, 3 times 0 is 0. And all we're left with is 1. So it's 1. Easy. But unfortunately, that was the only super easy one because we're back to more confusing ones. But at least we don't have negative numbers anymore. So I've plugged in 1, and let's go ahead and see what we get when we plug in 1. And then 1 plus 1, really hard, but it's 2. So we're going to put in 2 for y here. Let's keep going. We're going to plug in 2 for x, and you might be asking yourself, when are we going to stop? We're basically going to stop when we have something ridiculous like this again. Once we know that the graph isn't going to change again, like this when we have negative 62, then that's how we know that we're going to stop. So let's go ahead and plug in 2, which is 8, minus 5 is 3. So 3 is our number here. Let's plug in 3. And this should give you negative 26. So we're going to put in negative 26 here. So this is our final table here. And with this, we can figure out our zeros and relative maxima and minima. So first, let's look for zeros. The only problem is zeros are where y is 0, but y is not 0 in any of these, right? Well, we can actually figure out where y is going to be 0. Like, for example, here. Here we went from negative 1 to 6, and 0 is in between here. So this means that if we were to graph this, between negative 2 and negative 1, we crossed 0. We went from the negative numbers to the positive numbers. So in this case, we know that one of the zeros has to be between x equals negative 2 and x equals negative 1. Where else do we see that happening? Well, it stays positive for this whole time, but then it becomes negative again here. We switch signs, which means that 0 is in between here. We crossed 0 at some point. So we cross 0 at some point between x equals 2 and x equals 3. So let's write that down. So we have now found our zeros. Let's go ahead and find relative maxima and minima now. So remember that relative maxima are just like those hills where we have a big number that's the biggest number in a little group of numbers. So in this case, this number 6 is sticking out to me because we have a 6 here, and to the left and the right of it are both numbers that are smaller. So we had negative 1, we go up to 6, and then we go down to negative 1 again. So that suggests a hill. And here, x is negative 1. So we can say that there's going to be a relative maxima near negative 1. But remember, it might not be exactly negative 1, because there could be like a 7 or an 8 or something really close to this that we just don't know about. But in this case, it's going to be near negative 1. And do we see any others? Well, I see one right here. Here we have a 3, and to the left and the right of it are smaller numbers. We had a 2, we went up to 3, and then went back down to negative 26. So here we have another relative maximum, and this relative maximum is going to be at x equals 2, or near x equals 2. We don't know for sure, but it's going to be near x equals 2. Finally, we just need to find a relative minima, or the plural for minimum. It's the same thing, except we have a small number around bigger numbers. And I want to remind you that in this case, these two numbers here, negative 62 and negative 26, even though those are extremely small numbers, they are not going to be relative minima because they are not the valleys that we were talking about. For it to be a valley, it needs to have gone up on both sides. Well, the only one I'm seeing here is right here. And this is a relative minimum because it's a small number that's surrounded by numbers that are bigger than it. And in this case, we're going to have x equals 0. So our relative minimum and our only relative minimum is going to be near x equals 0. So there you go. We found the zeros, the relative maxima, and relative minima, or at least good estimates for where they are. So now you know how to find these things like zeros and relative extrema without having to even graph the polynomial. But chances are, if you're learning this, you also need to know how to graph it. So if you want to learn how to actually graph these, then you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching.